It doesn't.
Water does make objects appear
No,
larger.
it doesn't.
I think you're sort of like explaining it. Once it's in the medium, if it stays in that medium, the medium can't suddenly make it appear smaller as it gets closer to you. That's
exactly my point. Thank you.
Yeah, you were sort of explaining it wrong because yes, if a medium changes, then an object could appear smaller or larger.
That's right.
But if it stays in the same medium, it doesn't.
Right, magnifying glass.
More atmosphere with more water.
That's why
if you have a magnifying glass, you keep it fixed. You have like something behind it, and you move it back. It'll get bigger in the atmosphere.
That's two mediums.
So Taylor, to explain it to the water. So say you have your object, you put it in water, it appears bigger, right? If you put it deeper in water, does it still appear bigger, or does it, as it goes further away, does it actually appear smaller once it's in the water?
I think that once you put it through more water, it actually does change size.
It doesn't get smaller as it goes deeper?
I haven't looked at any studies on the size in water. I would have to look it up, but I will look it up.
You have to look this up, right?
Really? I mean, I'm not optics and the amount of refracted.
What you have to look this up. You have to look up whether or not objects appear smaller as they get more distant from you. You have to look that up.
Have you ever gone snorkeling before? Has a fish ever, as it comes closer to you, appear smaller?
So as you're looking through more of the refractive medium,
that would require leaving the basement. That doesn't happen.
I do
Taylor, there's no such thing as a refractive medium. Refraction requires a change in the refractive index between two different mediums. There is no such thing.
If you're looking through more water through the atmosphere, if you're looking through more humidity at different angles of the day, whenever you're looking through different angles of the atmosphere, could that affect it?
If there is a change in the refractive index in the air, but we're assuming a single medium, right? That would be multiple mediums if there's a change in index. See, what happens is that flat earthers saw that one television episode where they said atmospheric lensing, and then they misunderstood that to think that there are lenses in the air, and they don't understand at a fundamental elementary school level what refraction is and how the atmosphere works.
I think you're assuming, Brenda. You're assuming that the atmosphere is consistent, like a solid medium, when it's not. That's why we have gradient densities. So what happens when you stack multiple lenses back to back? And you try to look through it.
Atmospheric refraction happens when there is a gradient. Yes. Those are those are changing indexes of refraction. We're not talking about that. We're talking about a single medium with a single index of refraction.
Well, hold on.
Distant objects will never refract.
Right, but if your viewing angle to the object, right, as it starts to decrease on the horizon, starts to reduce its elevation angle, what happens?
If you you're
going to be, if it's over your head 90 degrees, right, you're looking right at it, straight at it. But as it starts to set, you're going to be looking through it from almost a horizontal angle. Go ahead.
When you see an object, when are you not looking straight at the object when you see an object?
I'm saying as the object starts to approach the horizon, right, it's going to get bigger and bigger and bigger because of atmospheric lensing. That's why the sun seems to maintain its resolution angle, right?
No,
it seems to
not what we're talking about.
All right.
Hey, Lion, did you find that documentation that says eyesight is logarithmic yet?
Not yet. Trust me. I promise you. I'm folding a tarp right now, dude. As soon as I'm done with this, I'm gonna retrieve that. Go fetch that for you.
Should I hold my breath?
No.
Right. So what he's talking about?
Yes.
I'm really folding a tarp right now.
What he's talking about is a study on the psychology of vision, and people were asked to point to where they thought things were in their field of vision. That's psychology. That's psychology. It has nothing to do with the geometry of the real world.
That's controversial and it's highly debated
No,
whether
it's not.
a physiological response why the moon seems to look larger on the horizon, or if it's because of atmospheric lensing. Now
That's
it's not
not
just
what
the
we're
moon;
talking
it's
about.
the sun. It's the sun because you're looking through a thicker section of the atmosphere, right? It's a cross section. You're looking through a horizontal layer to the sun. That's what's going to keep. That's why the sun seems to maintain its angular resolution because of the gradual atmospheric lensing as it starts to set into the horizon.
You're not looking for the alley experiment paper, Tora, about curved visual space?
Curved visual
do
space
that one.
is like it's curved visual space is just that. It's psychology. It's not reality. It's not geometry.
Yeah. Pull that paper
Those
up.
papers only operated on one axis, and the first
Also,
round of experiments only went 12 meters away.
So how does
curved visual space and logarithmic eyesight work together?
Because hold on, I'll just wait, dude. Just wait. Give me like 5 minutes. I'm done. I'm almost done.
In the experiment, it is interesting psychologically that the farther something away it was, the more the error in the perceived location of it by the human
it's people's
compounded. It was like they described it as hyperbolic visual space.
Yeah, it's a
at a certain distance.
psychological phenomenon. It is not the geometry of the world.
And for clarity, I understand. I've read the paper. Lyon has an outstanding claim that eyesight is logarithmic.
I don't even know what that would mean.
No, I didn't say no. See, you're strawmanning me because it is Euclidean in nature, right? Naturally, but it gets to a point where it goes from Euclidean geometry to parabolic geometry.
You mean hyperbolic?
Eyesight
the eyesight, our vision.
What is he even talking about?
I don't know.
I'll pull up the papers in a second.
He doesn't know
So it's
either.
a combination. It's a combination of Euclidean and parabolic geometry.
Hey, Lion.
When we look at the world past a certain distance, it stops being Euclidean. Now I know in your model, for your model to work, everything has to be perfectly Euclidean. Everything has to be exactly where where you see it. So the sun, the moon, the stars have to be exactly where you see them.
No,
that's not
nobody believes that. Nobody thinks that.
Minus 1% refraction.
Nobody thinks that everything is exactly as we see it. That's the opposite of science.
Right. We'll see.
But also, that doesn't support that eyesight is logarithmic.
Okay, well, give me a sec, dude. You keep asking. Just give me 5 minutes.
So the question on the table, as I understand it, is the question about whether or not the sun or other celestial bodies get smaller as they recede, get larger as they get closer to the observer, right? And we do not see this in the sun. The sun never changes its angular size during the day. It does during a year because our orbit is elliptical, but not during the day.
Or the moon.
Do you have a
Or the-
paper
or
on
the
that?
moon.
I'm just curious. I've been looking for one. Brenda.
Why would we need a paper to tell us?
Anything actually measuring it, right? Wouldn't you have to measure it to make that claim?
Why would I need a paper to tell me that close objects appear larger than distant objects?
No, about how the
I
sun
have
doesn't change that.
videos from Sir Richard Attenborough.
No, about the
I have videos from Sir Richard
Yeah,
Attenborough.
do I need a paper to tell me that when objects are close, they appear larger to me? Why
No,
do
I just
need a
asked
paper?
you for a paper for your claim about the sun not changing size.
But do you accept
Yeah.
that then? Because I think this has been a contention. Do you accept that objects, when they're close to me, appear larger than when they are further away?
In terms of atmosphere,
That's a natural phenomenon we observe naturally, yes.
Yeah, but
I
with the
didn't understand any of that. You talk over each other, can't understand either of you.
Sorry, go ahead, Taylor. Tyler, sorry.
yes, if the medium is isotropic.
You mean if there's a change in the index of refraction in the medium, right?
No, if there's no change. If there's no refractive
There's no
effects,
change.
as objects get closer, they should be larger.
If there's no change, then the light rays are going to travel in straight lines. They'll
That's
only
what I
curve,
said.
huh?
Yeah, I agree.
What?
I agree.
Okay.
Yep. That's what I said.
Yeah. So how does this not serve as a refuter to flat Earth?
Well, can you give me the paper about the sun not changing size throughout the day, please?
No, I'm not going to.
Okay, well then we don't have to get papers. Then what?
Yes, no, I'm not
Ryan, you don't have to worry
required.
about it anymore.
I'm
You don't have
not
to worry about
required
papers.
to provide you with elementary school level papers.
All right, Lion, we don't have to get papers anymore.
These
I've never
are
learned that in
elementary school. No, these are elementary school levels. I don't have to prove to you
Okay,
that
then we don't have to
I
prove
don't
it
have
either.
to prove, I don't have to prove like object permanence to you. I don't have to prove things
Well,
that
I
are
agree with
based.
that claim. I'm asking for the claim about the sun changing size. I just wanted to see a paper on it.
Yeah.
I'm not saying it doesn't happen. I'm just been looking for one anyway. So if you have one, just let me know.
How is that hard?
You're the one that made the claim. I'm just asking if there's anybody who's studied it.
Is there a paper that the sun exists?
I have looked this up on the internet. It took me all of 15 seconds.
Then
It's not hard. It's not hard to find. The question isn't hard to formulate. If you're incapable of asking Google, which is now basically an AI search, how much does the sun change in angular size in a year? Or does it
in a day.
if you can't do that, then you're not tall enough to be on this ride.
Okay, well, let's not prove our claims anymore.
Mate, don't write him anything.
The question is really simple. Just ask, does the
Right, so-
sun change in angular size during the day or in the course of its orbit around
Let's ask
the Earth's
some
orbit around the
more
Earth?
questions. Let's ask some more questions, right? Where's refraction? Is it most vivid nearer to the surface or up above? The higher you go, the less refraction.
It's stronger.
Right or wrong?
It's virtually zero when a celestial object is at zenith, then it's zero. It's zero.
It's zero. That's why when we look at the sun, it appears the same, yeah? So as it goes down, it's not going into the medium, it's still the same height, yeah? It's just going out of your perspective. But when you have to look at it, because it's so far away, you're looking through the medium with the refraction, and that's why it appears bigger. It's not because it's making it bigger, it's just appearing to be bigger. It's a kind of optical illusion, would you say? And what you're trying to do is pull a parlor trick. It doesn't change size. We're not saying it goes into the medium, we're looking through it.
I don't know who you're addressing, but there's also the question that the moon appears bigger when it's on the
subject.
The moon is on. Excuse me. The moon appears bigger when it's close to the horizon because it's close to objects of a familiar size, and so psychologically we register it as seeming larger than when it is directly overhead, because we can compare it to terrestrial objects, and it just seems bigger to us.
So
is a magnifying glass the medium?
Is that the deflection?
Yeah, I don't know.
We're talking about the sun. Now we've ended up talking about the moon.
No, we're talking about whether or not objects.
We're talking about the sun.
No, we're not.
Sun.
No, we're talking about do objects like the sun and the moon change in angular size due to their orbit around on the flat Earth versus the globe model? On the flat Earth model, they should change considerably.
Tell me what the flat Earth model is, because I forgot. Tell me what the flat Earth model.
The flat Earth model that has been used by almost everybody is
Who's everybody? How comes I don't know it? And you're telling everybody use it. I don't know it, so that's why I'm asking you to explain
One of the
it.
most important things is that the Earth is stationary, and it's in fact the moon and the sun that's traveling around the Earth, not the sun, not the Earth traveling around the sun.
Yeah, that
There you
they're
go.
following that the sun at least is following a racetrack, right, between the Tropic of Cancer and Tropic of Capricorn over the equator during the equinox.
So
Right.
I think the fact that they don't even have a model that they can
Well, where's your model?
Yeah, the fact that they don't even have one speaks plainly.
Where's
of
your
the
model?
validity of their
You
claim.
don't have a model. All you
Do
have
you know what a
is
model?
representation. You have
Yes, we do.
a digital representation. Could
No,
account for anything.
Schlitzie,
Yes, a representation of something that's of a real thing
Yes.
is called a model.
And if it don't
That's
work
what
out, and
that's
if the
what a
maths don't
model
work
is.
out,
A
and if the maths
representation
don't
of
He's
the
work
being
out,
dishonest.
then
He's
we can
pretending not
put
to
in
know
some
what the word
other
model
model.
means.
It just don't make any sense. You've got a
Well,
model. Show me
you're not
a
listening.
working
We just said we have a model. We have a digital representation of the reality of the world as we perceive it. That's called a model.
Yes,
Okay.
he's correct. That's what a
Okay.
model is. A model is not a physical three-dimensional object. It can be, but it doesn't have to be.
Not in your case. It could never be. You can never ever get that to work. Ever.
What? No,
Have you never
you
been
know
to
what
an
a model
elementary
is.
science?
You know
Have
what
you
a
never been
model
to an
is.
elementary science fair project? They have literally solar system models
No,
all
it's
the
only
time.
for gays.
He's being very, very disingenuous because first he pretends to not know what a model is, and then he is so sure that he knows what a model is that he says that our model doesn't even work. I mean, he's being
I'm only
dishonest.
critiquing your model. I'm only critiquing your model, and you're now telling me
Yeah, but you claim
you use
not
the
to
flat
know
Earth
what a model
model.
is.
And,
You claim
and
not to know what it
everyone
is.
knows this flat Earth model. I don't know what model it is, so I asked them to explain the model. Is that being disingenuous?
So Schitzler, here's
I don't
how
think so.
here's how you
You are
refute.
being disingenuous.
I just posted a model.
Here's how you refute a model.
What for a model?
Schlitzie,
I just posted a model.
Brenda, you know that, there's the
There's no
size of the, the one way of measuring the angular size of the sun is like using the solar sextant measurements, where they use a high altitude balloon and then measures it down to milliarc seconds of accuracy. So there you got rid of more or less all of the refractions. This is high altitude balloons with a very accurate instruments.
Stefan, no one's saying that the sun is getting bigger as it goes down, and for you to turn
but
it
that's
doesn't
how it works on a flat Earth. That's how it
You're
works.
failing to inform the people that when the
it necessarily.
Why are you interrupting? Why are you interrupting?
Because
Did I interrupt you?
Because I'm trying to make a point to you.
Did I interrupt you?
Yes, multiple times.
Let Schlitzie finish this one, please.
I just said, as the sun travels on its path, you will eventually be looking at it through, the whatever you want to call it, the atmosphere. It's not in that medium. It's not in that medium, but you will be looking through it, so it will appear. It's an optical illusion. It's really that simple. It's no big deal.
Appear what? It will appear what?
At the high altitude balloon at 100,000 feet, there is very, very little atmosphere as you are measuring the angle to the sun.
It's
right.
not.
So Schlitzie, I need you to make a prediction. I need you to make a prediction based on your model.
I haven't got no model. So what are you asking?
Then you're not tall enough to be on this ride.
Yeah,
I'm not old enough to be
You're not grown up enough to play with the big boys. Go play with the kids.
You don't have a model. If you don't have a model, you're not in the game.
Yeah, if you behave like a child, we're going to treat you as one.
A model.
It's really that simple.
I'm just critiquing your bullshit.
Okay, you can critique.
They don't need a model for that. You do not need a model to know that you've got holes in yours.
All right.
Okay,
so what you need to do then, Schlitzie,
you're being very disingenuous. You're being very disingenuous, and you know the reason why the sun.
Let me try. Hold on, Schlitzie. let's say that I'm going to American Magic Yacht Club and I am going to present a new design for their America's Cup race. And I walk in and I sit down in the middle of the meeting and I say, "Oh, I don't have a design. I'm just here to critique yours." How long before they throw me out of the boathouse?
How did you get invited?
Because I said I had a model that worked.
Yeah, but I'm not saying I've got a model.
Are you being intentionally ignorant? He gave you a very good example. He gave you a perfect example.
This is all this example was of how good Global's fuck up analogies.
Yeah,
It's really simple. Switzy.
Would you like me to try?
You're just doing politics. What you're doing is politics. It's funny.
Switzy.
And you think you've got it all worked out.
Yes, we
Come
do.
on.
We do.
You don't.
Let
It's not
me
rocket
see-
science.
Let me
This one
try.
has-
Don,
It's so boring.
Yeah, sorry.
Oh,
Go ahead.
In relation to other celestial objects.
Before we
Not
go
bad.
down that path, Lion just
yeah,
did
the
paper I've been waiting
Coriolis
on for a
effect.
little while.
The
Can I
Coriolis
respond to
effect
it?
$20,000 challenge. Yes, the Coriolis $20,000 challenge placed on this earth back in 2016 by a weapons expert and his sniper, Flat Earth, what's his name now? Flat Earth Sherman, that's it, sorry. Flat Earth Sherman is
Psychology.
It doesn't matter, dude. Our vision is both part physiological and psychological, dude. It doesn't matter. It's still, it doesn't change. It doesn't, why don't you rebuttal the argument instead of critiquing his credentials? Why don't you do that?
I'm trying to. Hang on. The paper states there's a difference between measurements and how we see it with our eyes. And the reason we know that we see just using our eyes in this particular manner is based on the fact that we do measurements. That's where we get the results from. The measurements are obviously accurate, while our human vision might affect what we observe.
It actually goes worse than that. The way that they were able to get those measurements was with a theodolite.
Yeah.
So your paper
through 7, and I went to each individual reference, and I got that, and I pulled that, and I posted that. That's what I did.
Can you tell me what your Google search was?
Hold on, we've been going on this for 10 minutes.
Oh my gosh!
Lion actually acknowledged
deviation from straight lines is irrelevant in close distances. But as distances increase, you have a more significant deviation from straight Euclidean lines, right? When we talk about Euclidean geometry, we're talking about what's the other guy's called? Damn it, like XY axis. What's that called? Cartesian space. It was slipping me. So in Cartesian space, we're dealing with straight lines. So in your globe model, when you look at the stars, when you look at the sun, you look at the moon, it's all graphed. Your coordinates are based on straight lines to those objects. Granted, you've now included 1% refraction, but what if it's way more than that?
Can I ask a question?
What's up?
Yeah, if you look at this, let's say the moon. Now you're saying, like, are you using stereoscopic vision when you look at the moon?
Yes.
It's inescapable.
Because you use 2 eyes, right?
Yes, but it doesn't matter. Even with binocular, is still the same. We still see the same. Even if you close one eye, you still have the same functions.
Any tool
So
that
you're saying that if you look with one eye, you still have stereoscopic vision.
Yes.
Oh God. Don't even try to understand the papers. It's pointless.
No, it's part of the physiological aspect of it. I mean, the psychological aspect of it. But hold on, you just say this before you can go. So, as objects move further away, right, our brains perceive shifts towards a hyperbolic function, where depth cues become less precise and distances appear to compress and distort our vision. So there's a blending of both Euclidean and hyperbolic perception that's reflected in these studies. And the complex nature of how humans interpret reality. Go ahead.
Sure, I grant you that. Does that change the elevation angle to the sun?
Yeah, it's 2020 vision. 2020. What do the 20s and the 20s represent?
How does it change the angle to the sun?
It doesn't, because what you're seeing there, you can interpret that as that angle, but you would be totally ignoring everything that he just said.
What did he say about looking directly at an object? But we can't.
Go ahead, Lion.
I'm talking about distance. I'm talking about
what did you say? Yeah, the angle is being
yeah, that'll help.
No, you asked him what did he say? So go ahead, Lion.
Yeah, how does it affect the angle, not the distance?
It's no longer Cartesian, or it's no longer Euclidean. So when you graph these things, you have to consider our vision. That's why I brought up the spherical dome, right? Oh, that's above us. You have this dome of perspective. It's a hemispherical dome that's over our heads. So everything arcs over our heads, even street lights, right? Everything has this, it's curved visual space. And you have to consider that with distance, there are things that are distorting because of, not only because of the atmospheric conditions, but the way that our brains perceive the world.
Sure.
Yeah,
So
when we
then
plug
we
in this
can't.
logarithmic math, we get better results with robotics.
Okay,
So
so
what if you
and this
what if
affects to
you
everything
use
that we
a
see, like the
mono?
horizon.
Yeah. But I mean, what
Yeah,
if you use
everything.
like a theodolite, which is just
Sure.
one, which is not a binocular vision,
It doesn't
and you
matter,
do
dude.
those measurements?
You're missing the whole point. It's how the mind translates the sensation. Okay?
Yeah,
That's
yeah, I
what's
know
going
that,
on.
but yeah. The thing was that
Can you see
they used like a theodolite
the light doesn't have a brain, though.
Yeah.
no,
How does
to measure the angles, to control
Okay,
and check
did
the
you
angles.
use
Then
did you
they
use
can I finish, please? And
no,
then
because
according to
you're
that
not making
yeah, and then
sense, dude.
Sorry, you don't understand what
they tested how
he's saying.
people observe it with their own.
Like what your mind is doing when where sensation turns to perception. Okay? That's
Yes,
what this is talking about.
Yeah.
Yeah, but if you look at the sun and if you measure the angle to the sun, you are looking at the same spot in the sky. So the elevation angle to the sun doesn't change whether you look at with the eyes or with a theodolite.
This
So
just
these
goes over
papers
their
have
head, I
nothing
think.
to
I
do
don't know.
with the location of the sun in the sky.
Yeah, I
Are you
know. In
being
your model,
willfully ignorant, dude? Are you literally being willfully ignorant to what I just said?
No, what you said made no sense. These
Okay, because you
papers
don't
have nothing to
understand
do
it,
with the elevation angle
that's
to the sun.
I can explain it further for you. So this is why I asked in the beginning, can you define sensation for me? And then can you also show how sensation produces perception and abstract ideas?
That has nothing to do with these papers about stereoscopic vision. Nothing.
the papers
And
literally are
obviously,
saying the same shit.
there is a difference between a monoocular and a binocular.
Yeah, these are the
Just
same.
using one or two lenses.
And these are the same papers that
You read
claimed
the paper, and that's what
wrong.
you think it's at. Do you think this paper is telling you the difference between monocular and binocular vision? That's what your claim is?
These are the papers that Clean
Is-
throws around. It's nothing to do with anything.
That's not what the paper says, dude. You didn't even. It's based off
Dude,
the
let
alley
me just read. Let me just read the abstract. It says Euclidean geometry is widely accepted as the model of our physical space. However, there is not a consistent model for our visual space. There is evidence that our eyes work to make pictures and images of the physical space using a hyperbolic model. You guys get it? I don't want to read the whole paper.
Eye vision versus what an actual machine does.
How do you think we made the actual machine, bro? We developed it off of our vision. Are you, dude? It's so ridiculous what you're saying.
This specific paper that I'm reading right now has nothing to do with robotics in Boston at all. This is nothing to do with Boston Dynamics, but there are papers on our artificial vision for robotics, but this is not that.
These guys think a camera was invented like by a blind person or something, dude. It's ridiculous.
It says in hyperbolic geometry.
Do we see an infrared?
In this paper, we are going to explore hyperbolic geometry and hyperbolic models of binocular. Hold on, let me just finish this. Hyperbolic models of binocular visual space and hyperbolic geometry. All the axioms of Euclidean geometry hold except the parallel postulate.
Okay, if we don't see an infrared, how did we create a machine that sees infrared? Because we're obviously
we understand. We understand how that.
We're obviously creating a machine that doesn't see the same way that we see things.
Are you saying there's no eyeball in the world that can see infrared? Is that your claim?
No, that's not what I said.
Okay, exactly. So we could have taken it from nature.
So not the way we see.
But this all started originally because you guys thought that the way that we see the stars and the sun and the moon is all linear. And I said, no, it's not linear. It's actually logarithmic also synonymous with hyperbolic, and it's curved. We see the sky as curved.
That's why we use tools, because the measurement is not involving the binocular hyperbolic vision functions. It's just a tool which is completely objective.
The
So,
tool
for
is
example,
developed from the human senses, bro. You
Right,
can't get away from that.
when you're
You
looking at the
just
sky,
wait.
and
I
you're
don't
Hey,
understand how
bro.
you're saying this.
well,
Infrared is not
bro,
based on
oh
the
my
human
goodness,
senses,
dude.
and we create infrared machines. So that doesn't make sense. It's not based off the human vision.
All right, the biggest example in these papers that we can all agree on, it says here, the models of hyperbolic parallel lines explain how we perceive parallel lines as curved, such as how railroad tracks going off into the distance appear to converge. That's one example of how our visions can distort. So even if you were to use a theodolite, it's not going to help in this case, because
No, it would, because
the
if you
railroads are
if
still
you
curving.
No, you're wrong. If you pointed the theodolite all the way down the line and then took the shot on the one rail, compared it to the shot on the other rail, you would see that they're still the same distance apart. So the
They look like
theodolite
they
would be able to
converge,
tell the
bro.
difference.
No,
They look like they
Theodolite would be able to
converge.
see. The theodolite would be able to tell the difference and would be able to tell you that they're not actually converging.
Yeah, of course. But the point is, at the convergence point where they both look to merge into one another, the theodolite sees that as well. And you cannot resolve between there being two tracks. You can just see that they look like they've merged into one. This is at the limitations of your vision, bro. That's what this is talking about. This is talking about
No,
how
it's
your
not.
mind. Yes, it does. This is how
No.
your mind defines the sensation around you. And this is what this paper is going off of. And you guys don't seem to grasp that concept. So, does anyone want to take a stab at defining sensation yet?
So when you use a theodolite and you put your crosshair on a target, does that crosshair actually put the point at the target, or does our subjective observation through the monocle fool us that we are missing the target?
See, the thing is, Stefan, is that in your model, you think the sun and the moon are actually going a geometric horizon. Like you
That was
really
not my
think it's
question. My question.
So when
Could you
you,
answer
but
the
I'm saying
question
when you
about
aim, when you
theodolite?
aim your, when you aim your theodolite at things in the distance, right? That declination that you observe with your eyes, you think it's because an actual curve of the Earth, a geometric curve of the Earth, not because of your your psychology.
So that means that if someone uses like a rifle scope or a theodolite and put the crosshair on the target, the target or the crosshair is not actually on the target. It's just our brain fooling us to think that it's pointing at the target. Is
That's
that
not
the
what
claim?
I'm saying at all. No, dude.
I
That's
might
not
be
what
able
I'm
to
saying
help
at
And
you
what
all.
answer
is the
this question,
problem?
because this is so I can actually probably help. So when I do my surveying, say for example, I'm trying to shoot a building corner far away, and even when I'm looking through the scope, I can't actually see like the interior corner of the thing. What I do with the theodolite is I pointed at it and I see the distance it's measuring, and I wait to the point where it's at the maximum distance in reading, and that's how I know I'm actually on the corner. So even though I'm looking through it and I can't see if I'm on the corner, the theodolite knows it's on the corner because it's the furthest possible distance. There you go.
I wasn't keeping track of that, dude. You said, I don't know.
So again, even when I look through the theodolite, the total station, I'm looking for a building corner, the interior building corner, like on the bricks where they form, like where they meet. Even when I'm looking through it, I can't see the exact corner it is because all the bricks blend together when they're that far away. But when I put the theodolite on it and I'm putting on a POL,
You're breaking up real bad, dude. We can't.
As I keep following that. Anything about that?
You broke up the whole way, dude.
Man, I really wondered what he was talking about.
Yeah, and Bunch already come out with a spiel.
I got one. I can't do anything right now. Am I still roboting?
No, you're good now. Go ahead, try again.
Okay. So I'm trying to hit an interior corner on the building. I don't know if you, what do you guys like? Do you know what that means?
Yeah, the inside of a corner of a building, like the interior angles of a triangle. What's up?
Okay. So when I'm looking through the theodolite, even while I'm looking through it, I can't see exactly where the corner is because it's like a far away shot. It's like whatever, 500, 600 feet away. I can read the distance on my data collector and it says right now you're whatever, 500 feet away. As I'm changing the angle, it says you're 501. Okay. As I keep going, now it starts decreasing. I'm at 500. I now know that the theodolite is actually reading.
When he gets to the point, he gets to the point of his story, it just starts breaking up.
I think it's got like a.
The thing is that our vision is mostly Euclidean.
I'm not,
but at great distances, like beyond 20 feet, it starts to slowly, very slowly, deviate, right? And then to the point where you start seeing shit like curving. Those things aren't actually curving though.
So, the point of my story, I'm not sure if I'm coming in clear, is that I'm not using my vision to see the interior corner. I'm using the distance that's reading on the data collector to do it. I'm not using
that doesn't apply.
I'm not using the scope, even though I'm looking through the scope. I'm using actual distance measurements that the laser is doing.
Now let's talk about.
So what's your point?
Let's talk about distances that are farther away and/or like celestial objects like Polaris or the sun. You're not going to get a distance with those. And the theodolites I have are older. They do not have incorporated distance meters. If I can't see the target, then you put a flashlight on it, or it's illuminated, or it's in high contrast.
There's another one. There's another one bites the dust.
The point I was making is that it doesn't matter if I'm looking through the thing. I'm using the actual instrument's data reading to judge if I'm actually on the corner or not the optics.
But why would you use a theodolite to measure a distance? Because that's not what they're designed for.
He said total station.
Yeah. So what?
The total station literally reads distances and angles. That's exactly what it does.
Yeah,
you wouldn't go down to measure a distance and pull out a total station. You can get a much accurate.
I am a land surveyor. I'm not licensed yet, but I literally
That's your job.
do
That's your job to have that though. So what you're doing is you're making use of your device, but it's not designed to take distance, and you know that. And
No, it is exactly what it is designed for.
Oh,
yeah, it has a laser ranger. No, it has a laser ranger built in it.
Designed.
It is designed with a laser.
Fundamentally designed to take distances. Can't you just admit that?
No,
Can you admit
it is.
that?
No,
It's
a
not
total station.
fundamentally designed.
You asked me 3 times.
How
I'll try
hard
to
is
answer
that
one
to
of them.
admit? How hard is that?
Okay, let me try to answer you before you jump on it, right? A total station has a laser ranger incorporated so it can measure angle and distance at the same time. Older theodolites do not have laser rangers, and they are just for measuring angles. And measuring distances with a total station is exactly what they're built for, exactly how they're utilized. It's the current state of technology today, purpose-built to measure distances and angles simultaneously.
Yeah, and I will agree with that because in the documentary, the convex tub, the full documentary, they used a laser beam which converged the beam, focused it, and they aimed it at a total station 21 miles away and hit it. Yeah. Okay. So that's fine. Okay. They hit the target at 21 miles away. So the total station does work. It's useful for range finding distance.
Yeah.
It's reliable enough.
Let me just read a citation. Total stations are primarily designed to measure angles, primarily, and elevations.
Rather than if you want, I'll give you the exact model. I use a Spectra Focus 50. I use a Geomax Zoom 90. I've used a Trimble S7. So why don't you look up those specific models and tell me if they measure angles and distances?
You didn't let me finish. I'm just tired of.
Yeah, go ahead.
No, just these guys will just talk over you. I wasn't about to say you can't, but the primary
the initial
reason
usage
for these machines being made is the angles, elevations.
That's its original
with
primary
the capability of doing distance as the machines have progressed.
To be fair, so
you
you did
wouldn't-
say. To be fair, you did say that you do have an older model. You did make that caveat when you were making those claims. You said I may have an older model. You did make that
It
caveat.
might most probably be more accurate than the newer models.
Now, my
That's the sad thing.
question is this. My question is this now. With all this optics talk, and Lion did a great effort in trying to get us to understand how our eyes work, and how, in the case of the Boston Dynamics robots, they had to use, I think, a Euclidean and another one. I missed the word there. Okay, in order to get this robot to work as well as a human, or even better in some cases. Is that proving that the Earth is an oblate spheroid? This is the point now, because I can see where this is going. We can't trust our eyes, but yet we use our eyes plus the tools to build buildings of great precision. And what's the word I'm looking for there? Verticality as well as horizontality. So, the point I'm trying to say is all this talk that we've had hasn't established that the Earth is an oblate spheroid actually rotating. That hasn't happened in that two hours of this nonsense. This is desperate behavior from the globers, as I said an hour ago, to try and keep the globe alive, but we're debunking it every step of the way. The one thing that is missing is your curvature. And that.
Okay, so it appears, Jin, that you are saying that these machines are accurate at doing what they do. So if we do the reciprocal zenith angle, if we do the reciprocal zenith angle test with these machines, we get, no matter where you are in the world, we get consistent results of the excess of 180 degrees, depending on how far the two objects are apart from each other.
Do you want to explain?
Look, we are not measuring curvature at all.
That does measure curvature.
That's what we need to do. We've got.
Do you want to tell them about EDM?
Yeah. Gordon Bennett, can I get my words out, please? We've got instruments that are precision that are showing us no curvature at all. And the number one for me at this moment that I like using is the in-flight telemetry data.
Right. So Jen. So Jen, if the instruments are showing no deviation from a horizontal, no curve to the Earth, then it would most likely mean that the curvature that we see in the sky, that when things go over what seems to be the curvature of the Earth, isn't actually that. And that's what I'm trying to explain to you guys. That what you guys perceive as a geometric curve isn't actually a geometric curve at all, because the Earth is flat. So what's actually going on here in our reality?
That's right. Plus, Tyler hit the nail on the head as well, just to recover from the, review. What she got correct is that the medium at times can magnify the sun on the horizon there. And there are times when the sun doesn't change its size as it goes across. And then another day, it does change its size as it goes across. I've got videos from Sir Richard Attenborough from Britain, who has videoed this stuff, this phenomena. So the medium itself, depending on the weather conditions and temperatures, can change the size of the sun, magnify it, make it look smaller. It's all happening. Optical illusions is what they are. They are happening on a flat Earth, bearing in mind we haven't established the Earth to be an oblate spheroid. No indication at all, no evidence, no physical experience. I'll stop there for now.
And then that's what optical experiments are showing in this paper by Wayne M. Zage from Boston University. He states this.
Thank you.
It says
Thank
here,
you very much for
we
your
do not
work there, Lion. That was good. And you had to stand your ground amidst all the incessant interruptions, but we finally understand. Thank you very much.
It says we do not often ask if the world we perceive by sight with normal vision is congruent to the physical world around us. And yet, daily experiences suggest that those two worlds are not congruent. So what you perceive to be the luminaries going over a geometric horizon, and you think that is congruent, that our vision is congruent with our reality, with the surface of the earth. What these experiments are showing is that they're not congruent.
Is it your contention I can't use those said luminaries to navigate?
No, I didn't say that.
Successfully arrive where I'm trying to go?
No.
Okay, so I can look at them and I can use them for navigation, but you don't like me using them because feelings?
I've never said that, dude.
Right, but the end of your argument says that we can't use them. But unfortunately for you, we do use them every single day, and they're accurate.
So even if we're gonna talk about like celestial
your
navigation, you still have to establish a flat baseline, dude. Like, and things curve, over that flat baseline anyway.
Hi, QE. You're a bitch, QE.
Is he? Why is he lying about that triangulation? Is he lying?
Yes.
Okay.
We do not use triangulation in celestial navigation, and except for one method, which I've never heard another person in this community talk about other than sailors. So, yeah.
Objects appear to converge in the distance. Also, in context where we may take physical space to hold on. Also, in context where we may take physical space to be unbounded, visual space is bounded. Thus, the sky appears dome-like, and astronomical objects like the sun or the moon appear to be at relatively small distances from the observer. Now, this is an actual paper. You guys asked me for paper. I got all the papers right here, dude.
To your actual paper, they're not actually those distances.
I'm saying this isn't from like a flat earther. This is from like a credible source, and you guys always beg us for.
And what discipline?
It's saying your credible source is saying that they appear to be moving in the sky, but they're not actually doing that, right?
What? Can you ask me that again?
Your source is psychology. It is not real science. Do you understand?
No, it's not just that. It's honestly a mystery to me why objects seem to converge. There seems to be multiple factors here at play. I wouldn't reduce it to pure psychology or pure physiology. There seems to be a combination of that, and also atmospheric conditions in the actual medium. that when we're looking through. So there's a lot going on here, guys.
Yeah. Okay. The question I have.
I'm going to go through this. Hold on.
No,
Larry,
give me one.
Please?
Give me one. The question I have is that paper. What's the discipline of that paper? Is it talking about metrology and geodesy and atmospherics, or is that talking about brain perception and vision?
Well, in this specific paper, it has to do with the psychology of vision, right? But
thank you very much. Thank you very much. Because when dealing with measuring of the Earth, measuring of distant points, measuring of celestial objects, we use metrology, geodesy, and atmospheric optics.
But my question is, and I'll go around this circle one more time. I'm going to grant you everything you want in this conversation. We don't know shit about what we're looking at, and everything we're looking at is in the wrong place. Granted. Now explain why celestial navigation works.
It's a coordinate transform, dude. That's all it is. It's a coordinate transform, bro.
What?
You've managed to, over hundreds of years of observation, and massaging the data, you've managed to make it work on the globe model in the south, which is it's awesome, dude. You guys have a working model. Great.
Tell me why it works.
No,
Is it because it's accurate?
Hold on. Before we get there, I'm not asking about the South. I'm asking if everything that you were arguing for and we're granting you about vision, and we don't know shit.
Our limit of vision. Hold on, dude. Hold on. As far as I know, I thought it was because of Polaris. That was a pole star. It doesn't move. It's what other star would you use? I mean, it's the only one that pretty much.
In navigation, it's better to use tropical stars. It's better to use tropical stars and stars that are on the northeast and northwest or southeast, southwest. That way you can get latitude and longitude at the same time. If you're observing Polaris, you can't get a longitude. That's what kind of makes it useless.
Yeah, I wasn't talking about longitude. I was talking about latitude.
You also said something else. You said something else that is demonstrably false.
Well, you can still see
you said something.
What do you use to establish? What did they use to establish latitudes?
Okay,
originally.
The first point of Aries.
Dude, I'm not talking about.
They used the celestial.
Oh my
pole.
gosh!
The equator. They did use the celestial pole, but as far as using the celestial pole for the to recognize the latitudes, Polaris is just another star. It's not at the celestial pole. It's just nearby. There are other stars that are also nearby.
I'm not denying any of that. I'm not denying that there's other stars next to Polaris. I know Polaris isn't necessarily at the very center of our cosmos like that. Nobody's saying that.
Right.
But Polaris seems to be a convenient star because it's the brightest star at the pole. It doesn't move. That's what you would use.
It does move. You just said it.
Stable.
Actually, a better star.
Hold on, dude. Can I finish though? Can I finish? Larry. So you brought up you brought up 0 degrees. Oh my God. Go ahead, dude.
So you're saying both Polaris doesn't move and Polaris is not at the center, and therefore moves at the same time. Both of those two things cannot be true. Which do you believe is true? A, Polaris is not at the center and therefore moves, or B, Polaris does not move.
Okay. You got to within reason, Polaris does not move. Granted, it does have a little mini ellipse, right? It does actually move over time. It's not literally at the very center. I already gave you that disclaimer, dude. Why are you using it against me? Beyond me. Clearly, you're not having a good faith conversation. So with that being said, Go ahead, dude. What do you got to say?
So
what?
Okay. You want to say Polaris doesn't move, but depending on the time of night, when I shoot distance from Polaris, I can get up to a minute of difference. That is 60 miles.
I know that. I said within reason, dude. Within reason, Polaris does have a little wobble. Yeah, thank you. So Polaris does have a little wobble, dude.
Yeah,
we
agree.
For the most part,
we agree.
The sky,
out right now,
like you guys are trying to
trip each other up.
It doesn't move, dude. Why are you being so pedantic?
Yeah, we're in agreement. Polaris is just nearby. It's 3/4 of a degree away, and it is useful in that manner. And another very useful star is the center star of the belt of Orion, which is also very close to the equator. So there we have.
Hold on. So this is what I was going to get into because he's being semantical, right? Because there's the reason that you have the radius that you have right now is because Polaris and Orion, right? So Orion is the ecliptic. 0 degrees to Orion is the ecliptic. That's literally the equator. So between the equator and Polaris, you have your lines of demarcation. That's how you get the radius of the globe.
Thank you very much. We now have the radius of the globe. Flat Earth has just died.
Oh, so why you guys have derived it? But anyway, Shubo, you get
Why are you saying that you wouldn't use Polaris to navigate?
I mean, you just did right there. But
Yeah,
Shubo,
but why would he
explain what
say
you just
that? Why
said.
would he
You
say
can't
that?
use
To
it.
find true,
You know.
you definitely use.
No, wait, everybody. He said primary. Again, these are.
Which is also very close to the equator. So there we have.
Hold on. So this is what I was going to get into because he's being semantical, right? Because there's
is 3/4 of a degree away, and it is useful in that manner. And another very useful star is the center